3.4 Quadratic models, building quadratic functions from data. 3.4 is very, very similar to 3.3 in that you will be finding vertices. The difference is now you're going to have to build those equations, the quadratic functions, to use. And then we will be finding maximum and minimum values based off of maybe a business type of a problem, a projectile in motion type of problem. So we're going to be looking at some real world situations here, but the kicker is you have to come up with the equations now. So it might seem like, oh my gosh, this is so much more difficult, but building the equations, not too tough. So just be patient with it, be patient with yourself, and just make sure you're following directions and taking your time and working through these. So we're going to go through example 1. This is going to be a lengthy video. There's a lot of work that is required for this video. So hang in there, fast forward the stuff that you don't need, but just make sure that you are paying attention and adding notes that you need to. So you can see for example 1 that I have highlighted P is the price and it is in dollars, and X stands for the quantity sold of a particular item. So the company that is selling whatever items they're selling has come up with the equation for their price. So I'm going to highlight that in blue also. So the price has its own equation. So in A, you are asked, and this equation you're actually going to need for some of your homework questions. The R equals X times P. We know P. P is given to us. Here's P. So to find R, express the revenue R as a function of X. That means R of X. And it equals X times, so I'm plugging into this guy right here, X times P, which is negative 1/6 X plus 100. Now all you have to do is distribute your X. So we get negative 1/6 X squared plus 100 X. So there's your quadratic equation for the revenue. So now in B, when it's talking about revenue, so here's my equation for revenue. What is the revenue if 200 units are sold? Actually, let me change that color. Units being sold is X. That's what we're selling. So what is the revenue when 200 units are sold? I am going to take 200 and I'm going to plug it in for X. So I go through, I do the math, bear with me. I have to do all this on my calculator. So I'm going to do 200 squared. And I'm going to get negative 1/6 times 40,000 plus 20,000. So I need to do this here, and in your calculator, do parentheses, negative 1 divided by 6, close the parentheses, and then it's times the 40,000. So times negative 1 divided by 6, and I get negative 1. And I'm rounding it to 2 decimal places here because we're talking money, plus the 20,000. So now I just need to add 20,000. And I end with $13,333.33. So if they were to sell 200 items, that company would then make $13,333. All right. Now we're going to move on to C and D. Now C and D, you're going to have questions like these on your quiz for 8, 9, and 10, where C is asking you what quantity X maximizes revenue. Now, when we see maximizes, we need to remember from the previous section 3.3, maximums happen when your parabola opens down, therefore your vertex is at the top. So this parabola, if you go back and look at your revenue equation, it is a negative x squared. So your quadratic does open down and it does have a maximum. So when I see that, I need to now think, oh, vertex, I'm finding the vertex. It's not going to specifically say you need to find the vertex. It is implied that you know how to find the vertex once you see maximum. You know that that's what you're looking for and you know how to find it. So on your quiz, just a heads up, it's not going to say vertex. It's going to say what is the maximum, what is the minimum. And we will add some of the other words that might be used, which you will see throughout this task, where maybe it's not just maximizes. You might see largest or the greatest or the most. Other words that represent maximizes. So when it says what quantity X, we need to remember X equals negative B over 2A. Well, if I remember my formula, or my equation for the revenue, let me move this down here. My revenue equation was negative 1/6 x squared plus 100. So I now am able to find, or 100x, I am now able to find the x coordinate of my vertex. So this is negative 100, negative b, over 2 times negative 1/6. You're welcome to do this in your calculator. I'm going to do some mental math here. 2 over 1, so this is negative 2 over 6. When you're dividing fractions, you are going to flip it up, and now it's going to become multiplication. So I take the reciprocal. It's negative 100 times negative 6 over 2. This is negative 100 times negative 3. 6 over 2 is negative 3. So we end with a positive 300. So we have now found X. So they need to sell 300 items to maximize the money that they are bringing in. Then it continues to ask, what is the maximum revenue? Well, that is now going to be finding the y coordinate of the vertex, which happens when you take your x and you plug it in. So revenue is going to equal negative 1/6 times 300 squared plus 100 times 300. So this is negative 1/6 times 90,000 plus 30,000. So this is negative 90,000 over 6 plus 30,000. So now I'm just going to use my calculator. Negative 90,000. And make sure you're plugging in correctly, you guys. It'd be wise for you to practice this right now. And then I'm going to add, so I've done so far the negative 90,000 over 6, and I got 15,000 negative, and then I'm going to add the 30,000, and I get that R equals $15,000. So if they sell 300 items, they are going to make $15,000. And then in D, when it's asking us what price should the company charge to maximize revenue. So I see maximize here, which now we need to be thinking, oh, maybe this is vertex. Well, we've already kind of figured out that, oh, the maximum I have to sell is 300. So the question is, what price? Well, if we remember back to the first part, price is negative 1/6x plus 100. Let me double check that. Yep. Price is negative 16x plus 100. So we already know the maximum number that they need to sell is 300. So now I just need to take 300, plug it in for x. So I get negative 300 over 6. This is negative 50 plus 100 is 50. So they need to charge $50 for whatever it is they're selling. 50 bucks is what they need to make sure that they charge, no less. Otherwise, they won't make as much money. All right, example 2. So example 2, hold on, I need to get a drink of water. All right. Example 2 is about maximizing space, where the last example was maximizing our profits and the money that we're bringing in. Now we want to maximize the space that we might be working with. So David has 400 yards of fencing and wishes to enclose a rectangular area. And then it goes on to say we want to express the area as a function of the width. So when I am given 400 yards of fencing and I want to make a rectangle, I'm going to start by drawing a rectangle. Now the fencing is what goes around. Hopefully you remember from our early math days, what is around is the perimeter. So I know my perimeter equals 400. How do we find the perimeter? We find the perimeter by adding all the side lengths. Well, I don't know the side lengths yet, but I know that I have 2 lengths and I have 2 widths. So perimeter is length plus width plus width. Well, I know the perimeter. The perimeter is 400, and I have 2 L's and I have 2 W's. Now the question is, express the area. Well, we need to remember area is length times width. Now I continue reading. Express the area of the rectangle, so I have that, as a function of the width, which means I wanted A of W, which means L, I want W only. L cannot be there. So I need to find something I can replace L with. So I'm going to use my perimeter. I want to solve for L. So then I can substitute that in. So I'm going to subtract 2W. 400 minus 2W equals 2L. And then I'm going to divide everything by 2. So 200 minus W equals L. That's what I'm going to plug in for L over here. So this is going to be 200 minus W times W. Because it is multiplication, I distribute and I get 200W minus W squared. We are used to seeing the squared first. So A sub W equals negative W squared plus 200W. So there's our function. Now we're going to use that function to answer the next questions in this example. So for what value W is the area largest? Largest. Hold on, let me get the pin working. Largest. It's still not wanting to work. There it goes. That means my mouse keeps moving. I'm going to deal with vertex. Maximizing. It's a maximum because our parabola opens down because it's a negative W squared. So we are looking for it says the W. What is the value of W? Now if I'm looking at this, I have A sub W equals negative W squared. What was it? Plus 200W. W is in place of X. This is the same as negative X squared plus 200X. So please don't get that confused. So when it's saying find the value of W, It's just another way of saying find the x-coordinate of the vertex. So we have negative b over 2a. So negative 200 over 2 times negative 1. So I'm just going to go through the math now. So the width would have to be 100 feet in order to maximize this space. Now, let's just talk about this really quick because you do have a question like this on your quiz. So if I have a rectangle and I know that one side is 100, you automatically know from the properties of rectangles that the opposite side is congruent. It is also 100. So I had 400 feet of fencing and I have now used 200, which leaves me 200 for both sides that are left. So if I do 200 divided by two sides, well, that leaves 100. So the other sides are also 100 apiece. And think about what shape this is. If all four sides are congruent, what shape do we have here? And then that shape is very, very special. That is the shape that will maximize everything. And this will help you on your quiz. Okay, if you can remember what this shape is, I'm not going to give it to you, but if you know what this shape is and you are able to use that understanding to help you answer your quiz question, I am okay with that. Okay, but if not, you can go through and do this work. So you can decide. But I'm not giving you the name of this shape. That you should know. Now in C, it is asking you for the maximum area. Well, area, if I look back at my formula or my function, I found W. Now I need to find the area. Well, guess what this equation is for? It's for finding the area. So I found W. Now I'm going to plug in and find, go away. I'm going to plug in for W. That will now help me find the area. So I'm going to have negative 100 squared plus 200 times 100. So this is negative 10,000. The negative does not go away. I am not squaring the negative. I'm only squaring the 100 plus 20,000. And when you add those, you get 10,000 squared feet, or feet squared. So that will be the maximum area that you can get with the perimeter of 400. All right. Now for the last one. Now, this last one, I really am only going to talk about examples A and B. And then I'm going to give you a little hint on C because you have a question on your quiz that is like C. So I'm just going to do a little bit there. I'm really not going to do too much with C. We'll be here all day if I were to go over this completely. Now, here they're giving you the equation. That's nice. You didn't have to come up with that on your own. It's just a projectile's being fired from a cannon. So like when maybe they put a t-shirt in a cannon and they shoot it out into a crowd. That makes the parabola. So it's being shot up into the air and then it's going down. So they've already created this equation where x is the horizontal distance. So let me finish highlighting that. X is the distance and h is your height. The height h, let me not use pink. It kind of is not working too good here. H is your height. The h of x is the height at a certain distance that the projectile has been shot. So we're going to go through this at what horizontal distance, so that's x, at what horizontal let's see, it says max. Sorry, I was reading it a little bit. At what horizontal distance from the cliff is the height of the projectile a max? Oh, maximum. That means we might have to find, or will have to find, part or all of the vertex. Now, knowing that I need to find the vertex, I need to remember that x equals negative b over 2a. So I have here my b, I already have that circled, and I have my a. A is with the x squared, b is with the x. So this is where it gets kind of tricky. B is nice, negative 1. But it's 2 times a. A is negative 32 over 50 squared. Well, I want to simplify negative 32 over 50 squared. 50 squared is 2,500. So this is negative 1 over, and then if I multiply these two, I get negative 64 over 2,500. Because I am dividing by a fraction, I'm going to take my fraction and take the reciprocal, which will now change to multiplication. So negative 2,500 over 64. Because I have two negatives, these will become positive. I'm multiplying by 1. So that's not going to change anything. It's just 2,500 divided by 64, which gives me 39.0625 feet. I'm actually going to just go with 39 feet. It's nicer to work with. It's a nicer answer. I know I say, decimals, you got to be exact, and now I'm rounding this off. When we go to B, there's a reason for this. If I were to ask just for the horizontal distance, yes, I would want 39.0625. But in B, it's asking for now the maximum height. So we found the x-coordinate of the vertex, but the height is the y-coordinate of the vertex. So now I have to plug in that 39. And that's going to be very ugly if I am using the 39.0625 or whatever it is. So I have negative 32 over 50 squared, and then it's x squared. So 39 squared. Let me double check that that's correct. Okay, plus x, which is 39, plus 200. So lots of calculator work right now, you guys. So it's negative 32 over 2,500. Now 39 squared is 1521. And this is plus 239. So I've just combined those. So I am going to multiply the 32 and the 1251. So, 1521. Whew. 1521 times negative 32 gives me negative 48,672. Now I'm going to divide. I'll show this so that way you guys have it. Negative 48,672 divided by 2,500. And then we're going to add 239. So divided by 2,500. And now I'm going to add 239. And I am at a height of 219.53 feet. A lot easier to work with that whole number of 39. Again, I know I'm always telling you, don't round and whatnot, but in this case, it's just going to make your life a lot easier. All right. Now we're going to move on to C. C is asking, at what horizontal distance from the cliff will the projectile strike water? This one, unfortunately, is not factorable, and you would need to go through and use the quadratic formula. Other than what's in your notes, I'm not going to go through that with you. What I'm going to give you right now is a hypothetical, so that way you're a little bit more prepared for what will be on your quiz. Now, when it's striking the water, if I have an h of t, let's say we have an h of t, which is the height after so long. And let's say I have, negative 2.7, so we're not dealing with the fraction, t squared plus, 72. And it wants, when is at what horizontal distance will it land on the ground again? That means your height would be 0. On the ground, the height is 0. Now remember, this is a hypothetical, you guys. I'm just coming up with this equation. So that way you guys have something to maybe follow on your quiz. Because it's not as difficult as the one in this example. Because you only have a t squared, that actually makes this very nice. And I'm going to start by subtracting 72. So I get negative 72 equals negative 2.7 t squared. Now some of you are probably already thinking, I can square root this now. Not yet. Don't square root yet. You have to move the 2.7 first. So I'm going to do negative 72 divided by negative 2.7. And I get 26.666666666 repeated. But I'm going to leave that decimal in my calculator. Now I can square root. So I'm going to square root that answer, that decimal, or put a whole bunch of 6's in there. And you end up with a time of 51.164. And if we're talking seconds. If it says minutes, minutes. So after 5 seconds, this projectile would hit the ground, or 5 minutes, or 5 hours, whatever, 5 days, whatever it is. Okay, so that's more similar to what is going to be on your quiz. So if you're watching this, you'll have that hint. And again, if I have a mathematical error in that last example, it's just not seeming right to me, but it might be. If I do have an error, just point it out to me and I will fix it. Otherwise, I will see you in class tomorrow with any questions that you might have from any of these examples and anything that you need some clarification on. So come ready with those questions or issues that you may have. Bye.